Okay.
You must mute your mic when your parents are coming in so we don't hear the arguments. Okay, as I've said before, I will record this session. It's already started, and I just want to do a short demonstration again. We don't know how the future looks like for the country. Our leaders are not making very good decisions, but we will try our best to educate you guys. So the last time you guys were here, I spoke about the apps that you need on your phone if you are using your phone to attend classes or to do Google Classroom. So on your phone, you need Google Classroom. This one, I believe it's an app smaller than WhatsApp, smaller than any of these games that you see here. You need Adobe Acrobat PDF Reader, the red one over here, all right? And you need Adobe Scan. The scan is if you are working on pen and paper and you want to upload your work, this one will help you upload your work on pen and paper. And this one will help you read the instructions and informations that we give you from Google Classroom as well. So for example, this is from a textbook. If you have this one, you can also edit it by adding a comment and using a pen and writing with your finger on the thing and say this is equals to 4. I'm just giving an example. I don't know if it's 4, right? This is coordinate, so it's not 4, right? So that is the example that we are giving to you guys, all right? So this is why those apps are very important. And once you are done with the apps, you can always upload them onto Google Classroom straight. It's supported by Google Classroom as well. So this is when you take a picture of something, of your notebook. Maybe you wrote down the answer in your notebook and you took a picture, and then you take a picture with this app. You scan it, you give it a name, save it, and then you just click on share. And at the bottom here, it says share a copy. When you click on share a copy, Google Classroom is already there. You click on Google Classroom and I will receive your answers that were on pen and paper. All right. So very important apps that we must have. So for example, you can see this one was homework solution, 12 April 2021. Somebody wrote down the answers and it was on pen and paper, but I could see it in Google Classroom, and they can also give the answers straightforward using the app. So those are the 2 apps, 3 of them that you must have. Google Classroom, just to refresh you. Please note the view looks like how it would look like on your mobile phone. All right, so on your mobile phone, you are grade 9As or 9Cs. This is where you'll find your classwork. You can see we have a lot of things here. A lot of you don't have textbooks. I've also uploaded a textbook, and you see that PDF Word. If you have the PDF Acrobat, it will allow you to use the textbook as well. Let me just quickly open up this textbook to see if it will open up on the mobile phone. So because I have that Adobe Scan, it should definitely open up as well. So this is the one we are using. And you will see what we are currently busy with is problem solving algorithms and so forth, pseudocodes, flowchart, and programming concepts and so forth, right? So those are the ones that we are doing, and it opens up, okay? So those are the textbooks that I have provided, and then the rest of the notes I will provide to you through Google Classroom on a given topic that we have. Right, so make sure those apps are on. Apart from the games, delete them. We don't need them for now. We have to proceed. This was the last thing we did last week. I'm not sure when last did we do. I just want to make it big so that we can look at it. So we started with a function, all right, how to define a function. We talked about function signatures. I also uploaded the PowerPoint PowerPoint presentation, and we also discussed it a little bit. So there was a question last time, and somebody said, "Sir, can you please re-explain these things again and use flowcharts as an example?" So we have to create a function using flowcharts instead of using pseudocode. So that is now what is being requested. I'm just trying to look at some previous questions if I have any flowcharts somewhere. I don't have a flowchart over here. Just quickly looking for a flowchart that we can use. Flowchart.
So,
Yes.
quick question. Are we still writing semi-external?
Yes,
The grade 9.
you are writing. It's an exit exam. It's compulsory for you to write it. So I think the only people that will get away probably again, which will be useless, might be grade 8 and grade 10. The rest of us is exams. You must prepare for exams. There is no other solution. Okay, I'm just quickly looking for a flowchart that we can use. Yes, here is one flowchart that we can use. Okay. So let's break down the flowchart because we also need to code it, and then from the code of the flowchart, we can also create a function for something that we need to do, something that we need to check, and so forth. I'm trying to make it small. Let me just screenshot it. It's better. Okay. So over here we have the flowchart. I would like to go through the flowchart a little bit so that we can at least see what it is we are working with. So within the flowchart, okay, you can all hear me. Can I start with the presentation, or is there any other question first before I continue?
Yes, sir.
And what is the questions? What is the question? Was it yes for the question or yes to start?
Yes, sir, can start.
Okay. So over here we have a flowchart, and the flowchart, we always have to try and interpret it one way or another. But let's just go through the flowchart as well. So you can see here by the arrow that we have, there is a loop taking place. And so this means we need to loop something as well. We just need to find out what is the loop that we are doing. There is another loop over here that we also need to look carefully at if there's a loop or it's just a straight decision process. So the first one is S equals to 0. This is initialization, okay? We always call it ini, initialization. C equals to 1. This is another initialization, okay? It doesn't matter what the top part is. We don't know where it's coming from. It can be anything, right? S can be sum, C can be costs. It doesn't matter, or count, right? And then it says here input n. So n can be number. So this is our input. Okay, we know it's input. Forgive my ugly writing. I'm writing with the mouse again. So that is an input. And then here we have a process. T equals to n divided by 100. So that just divided by 100. And then is t greater than 1? If yes, then it says is t greater than or equal to 0.1? No, sorry, is t smaller than 1? Then it checks. If it's yes, then we check again. Is t greater than or equal to 0.1? If it's yes, then we say s equals s plus 1. Okay, then we put in the s over there. We change it. If it's no, we say c equals to c plus 1. And then we check is c equals to 10. If it's no, is c smaller than 10? If it's yes, we go back to the process. If it's no, we go out and we output S. So we basically want to find S. All right, so that is the flowchart. I would like us to quickly do a trace table for this flowchart because whenever you get an algorithm, your first instinct must be trace table, trace table, trace table, trace table. So let's first look at a trace table for that one. And we will be working with Excel again. Excel is just a nice way for us to quickly do everything together. Is there somebody who would like to tackle the trace table for us? Remember, this will be one of our tests and topic tasks that we will be using. So you have to know how to do it and you have to try now. So trying now is always a good idea to see if you understand it or not. That way we know we are on the right track, or we need to explain something over again. Any takers, but you must move fast at least. We want to do a trace table for this one, all right? To make it easier for some of you, let me give numbers to the trace table. So the first block, each block will have a number. This block is called number 1. This block is called number 2. This block is called number 3. This block is called number 4. This block is called number 5. Okay, since this block is going out, we don't want to go out. We will go to this block. This block is number 6. Since this block is going out, we don't want to go out. This block is number 7. And both of them are going out. So this block will be number 8. This block will be number 9. And this block will be number 10. Okay. Should I just do this one, or is there somebody who wants to try at least? Or are you guys already tired of school?
So just do it.
Okay, sorry, who's Galaxy A2 core? Galaxy A2 core. Okay, so if somebody is not saying who they are, then I'll just kick you. And then please send me a text message to put you back. You have to say who you are, otherwise I will kick you. Galaxy A2 core. Or even type in the chat if you cannot talk. I just need a name. Okay. Let us proceed. So it's very important, guys, that you identify yourself. That way we don't have unwanted people doing funny things and then you don't know who it is. But at least if I see the names, I know what is going on. All right, so let's go through it again. Since school was, or class was a long time ago, we will always have numbers in the first column, followed by our variables. So the first variable here is called S. So luckily for us, we don't need to type too many things. We just name it S. Let me just center everything. It's always nice to center. Looks much better for viewing. The second variable is called C. So I will have a C. Then I have an input for N. So there's another variable called N. Then I have another variable called T, which we get from the N. So that will be T. Then whenever you see a diamond box means we have a decision, right? We have a decision. And let me just put it over on this side. So after we have a decision, we have C. Okay, we already have a placeholder for C. We have a decision again. We already have a decision, so we don't need two decisions. We already have S over here, and then we have output. So the last one will be output. All right, just make the U. Right, so this is our...
So your mic is lagging. We can't hear you.
Is my mic lagging? It's impossible. That cannot be true. My mic is not supposed to lag. The internet is very fast here. I'm just checking again. So maybe it's your internet connection from that side. Is there anybody else that I'm lagging also? Zoe, Dina, am I lagging from your side?
So you were a few minutes ago, but now you stopped.
Okay, my internet is very fast. If you see there, it says it's running at 30 something. So it's very fast still. Okay, but we will see. For this mass, I've explained how we got the different variables for our trace table. And now I'm going to go through the trace table, all right, step by step, each row, each column, and each row. So for row 1, it says S gets a 0. In column row 2, it says C gets a 1. So then I go to 3. 3 says input N. Now, we will always give you N's. If we ask you inputs, let's say, let me go back to the question. In the question here, I just took the trace table. I did not take what the N's are for. So you will see here, here is the example of the trace table that you will have to complete. And for the trace table, we give you this numbers over here. So these numbers here are our different N's that we will have to use, okay? So let me just quickly copy that, and I will paste them inside here so that we can see these are the numbers that we will be using. Okay, let me just quickly merge this, merge the center. All right, so those are the N's that we have to use for this given trace table. All right, so N, the first N is 15. So I put in 15. I go to number 4. Number 4 says T equals N divided by 100. So I will put in equals to the N, and then we divide it by 100. I get this number. Then we go into the decision. Is the number 5. Is T smaller than 1? Yes. 0.15 is smaller than 1. If it's yes, you go to number 6. So at number 6, it asks again, is T bigger than 0.1? This T, is it bigger than 0.1? Yes, it's bigger than 0.1. That means you go to number 7. So at number 7, it says S equals to S plus 1. So here is the S. We must just now put it equals to the 0 plus the 1. That is the equals to. We get the 1. And then it says you go out all the way back to number 8. So we are at number 8. So now number 8 asks us another decision. Is C smaller than 10? Is my C smaller than 10? Then my decision will be yes. Now, what I did not tell you before, so this is what we call a repeat until loop. Okay, so what are we repeating? We are repeating 3, 4, 5, probably 6, 7, 8. Those are the ones we are repeating, but 3, 4, 5 is always going to be there. 6, 7 depends on what happens here. And 8 is always going to be the one that we will always go out with. And then we know that we have to do this 10 times. So what that tells me that is in the C, when I will stop somewhere is where my C will be 10. That is where I will stop. Once I reach 10 for C, then I know when I come here, it will just go out. Okay, so here it will be 9. Then I will go back in, do these things, and then my C will become 10. When its C is 10, then I will go out. So that is where I will stop. Okay, stop only when your C is 10. So I must do all of this 3, 4, 5, 3, 4, 5 until the C is 10. Okay, so I know I'm going to do 3, 4, 5. So in my answer already, I will have 3, 4, 5. Okay. When we come to 8, I will have 3, 4, 5. Every time I'm at 8, I will have 3, 4, 5. Okay. So this is now where the thing that I will always repeat. Every time I reach 8, I'll have 3, 4, 5. Okay. So here we said, yes, C is smaller than 10. That is the C. So we go back to 3. We put in another number. What is the next number? The next number is 8. Okay. And then we do the same thing, what we did. After that, we go to 4. We say that T will be n divided by 8. So we'll say equals to this, n divided by 100, sorry. That's 0.08. Number 5 says, is T smaller than 1? We will have a yes. Number 6 says, is your T bigger than 0.1? So my answer here is no, because 0.8 is not bigger than or equal to 0.1. So if it's no, we will already go out into number 8, right? So we will go to 8, and I already know when I reach 8, I will have 8, 3, 4, 5. Okay, so what is at 8 is count. First at 8, it says your count will have a 1. So it will be C equals to C plus 1. So it will be 1 plus 1 equals to 1 plus 1. That is what I have. It's a 2. And then I have to go back to number, sorry, I missed a number here. Not 8, it's supposed to be 9. Sorry, this is 8, this is 9, 10. So I missed a number here. Let me just quickly go up. The first one here, the C, let me just insert. It's gonna be 9, and this is supposed to be at 9, and this is supposed to be 2, because we had to add the C. So this is equals to 1 plus 1. Just correct that. Sorry, I missed number 9 here. My ugly handwriting. Number 9 is where the decision is and not at number 8. So over here we have 8, and then we should have 9. So 9 is where the decision is. So at the decision, we will check again, is the C smaller than 10? Then that will be yes, it's smaller. So yes, it's smaller, and then we do 3, 4, 5 again. So 3 input the next number. The next number is 251. So that will be here, 251. And then we continue to number 4, which means you take that 251 and you divide it by 100. So that equals to that, right? Equals to 251 divided by 100. Okay, I'm going to stop here quickly after this one. And then number 5, is T smaller than 1? So number 5 will be no. Then we go to number 8. And after 8, we have to go to 9. So number 8, the count will be now 3. Number 9, we will check, and our answer will be no. And then we come back at number 3, 4, 5. Okay, so now guys, this is now one of those things that, okay, for an exam or for a test or whatever we have, you will have to do it, because we will mark it according to what you have over here. Okay, so you can see we are already at 3. We are not always going to do everything, because some of these numbers will be bigger than 1. And you can also predetermine what it is, but I will leave this for you to complete at home. That is the trace table. So the trace table just will give us the correct answer at the end. That is just what I wanted to show you from using a flowchart to complete the trace table. That is the way we go. You just follow the arrows, you just follow the arrows, you just keep following the arrows until there are no more arrows to follow. And that is what we do. All right. So the reason I'm also stopping is because you will see it becomes tiring now. Okay. It's like we're doing the same things over and over and over again. This is now where that same things over and over again, it's easier for us to code. All right. So that is where I want us to look or focus on. So we want now to code this process, and I don't want to make too many lines of code, because if we have to do this loop and then it goes into that and all those things are there. So let's first code directly as it is, and then after the code we will now check if we can create a function that will check for us some of these things, or if we can change one of the things into a function and then just call the function all the time. That way it also makes a little bit sense for you guys. And I'll give you a final example with a function in terms of normal calculators that we use on an everyday basis as well. All right. So to code, we will just start by saying S is 0. That is what is on the flowchart. C equals to 1. That is on the flowchart. And now we have to basically do a do while loop. Okay. So a do while is repeat until, and I did not explain the repeat untils to you guys. So I just quickly want to go to our notes that we had before. This one over here. I just want to go to the notes quickly. Please remember, it's always good to go to reference so that you can see what we are referring to. And here we are looking at loops. All right, this was a while loop. We said while this is true, we will do. Okay, and while loop display input. No. Okay, so they don't also have a repeat until here. They only have a while loop. Okay, so with the do while, how it normally works is you will always say do first. Do, I'm now just giving you the thing. So it will say do, and then you will say this is now what you will do, statement, and then you'll have another statement, and then you will put here at the end of the do, you'll say while, and then you put in the condition, and our condition is while C is less than 10. Okay, so you will first have your do, all right, something like this, and then you will say your statement, and after you have your statements, then you put your condition. All right, so in our case, we don't have that kind of loop defined in our notes, so it will be very difficult to explain to you how we will write it down. So I will just create a normal while loop. Okay, so we will now check at number 9 that we have. I'm looking for my pen. This part here that we have over here, I have moved it up now to where we want to start the checking process. Okay. I hope it makes sense also a little bit. I'm modifying this because we don't have a repeat until, let me see if I can call repeat. Okay, repeat is also not a function in Phony. So so what I'll do is I'm now just trying to I'm just trying to put this into the front. So normally they say you will put do, and then you will put into brackets what we need to do. And after we put into brackets what we need to do, we will close, and then we will say while. And in this while, we will now put our condition, which would be C is less than 10. All right. So this is normally how they want us to do the do while loop. So in this do, we are now doing this input number and all those other things that is in there. This is how it looks like, the original one. But I did not explain this to you, so I don't know if most of you will understand it. In the textbook, you will see it's called like this. It's called repeat, all right? So instead of a do here, you will have a repeat. And instead of a while, you will have a until, okay? So it will say until C is greater than 10. Okay, so this is basically what the do while means. Is that clear to you guys, or should I explain more, or it's just fine? Hello?
So,
Yes?
so the do is like the loop for the function.
Yes.
Okay, thank you, sir.
But remember in the notes, let me just, instead of just saying remember, let me just show you. Algorithm. I'm just looking for notes, algorithm notes. Okay, so this is the notes that we shared. So I want to go to loops so that I can just again show you what we're talking about. So in a loop structure, we have 3 different types of loops, okay? The for loop is easy. We just know we need to count. Then you have a while loop. The while loop is now what I tried to do before. And then you will have this one, the repeat until, okay? So this is now what we call the do while, right, in Python. But in the notes, it's called repeat until, okay? So we are repeating something until the condition is met, and we are going back up. So you will see the way this flowchart looks like. It's the same as the one in the question. It's the same as the one in the question over here. And just go back to the question so that you can see. So you will see that here is the decision made, and we are going back up, okay? And that is now why I'm calling it a repeat until. But when we are coding, there's nothing called repeat until in coding. This does not exist. And this is why I thought of either trying to change it into a while do or a for loop, because we know how many times we need to do it. But that is basically what we have to do. All right. So I hope that also clarifies out the repeat is the do. Open the brackets, we will do something in that brackets, and the while this is your until, okay, until C. So your until here will be until C equals to 10 and not until C is less than 10. So it will repeat, and then until the C is 10, then it will go out. All right. So every time it's less than 10, it will do this. And when it's not less than 10, it will go out. That's why the until has a different value in there. All right. So let's continue with the code. So we have a variable n, which will be equals to, and is there, I always ask people to put in here what we need to do. So we have input, and we said we want the input from the user, and we also say we want to make this an integer from the input, and we will say enter num. Let me just make this a little bit visible. Close the assistant. So we want the user to enter a number, the given number from the list, That is where we have our input. All right. So please note again, this is like the standard way. I want an integer because we are working with numbers. Let me just confirm. Is there any decimal numbers? No. So all of these numbers are whole numbers. So if it's whole numbers, we call it int. If it's decimal numbers, we call it float. Okay. That is the same as saying this is just a number and the other one will be currency. Float is currency. All right. Let's proceed. So after that, we can close this. After that, we take in the number. So after we take in that number, then we have a variable called t. All right, let's just put it in the same line. A variable t, which will be equals to, and we said it's the n divided by 100. That is what the t will be equals to. So the computer will already know that t will be a float, okay? And then after that, we have a decision. Now we say if t is less than 1, all right? Remember after the decisions, let's put it in there. If t less than 1, and then I don't know why my if is not working fine. Okay, I don't know why my if is not working. Right, so the if is supposed to automatically space, so it seems like there's a problem somewhere here. I just have to check, carefully check it what the problem will be. But let me just continue.